Pluto might have lost its status as a planet, but it remains a fascinating celestial object for scientists who now have a powerful tool to study it, the James Webb Space Telescope. Thanks to this new generation space observatory, scientists are making astounding discoveries, and what they've found on Pluto is nothing but mind-boggling. What have scientists found on Pluto? How does it affect you here on Earth? And can these new discoveries make Pluto qualify as a planet again? Join us in this video as we dive into the James Webb Space Telescope's terrifying discovery on Pluto that changes everything. The James Webb Space Telescope might have been crazy expensive and very complicated to manufacture and launch, however the effort is paying huge dividends already just months into its operation. One of the main uses of the JWST is to study the atmosphere of exoplanets to search for the building blocks of life elsewhere in the universe, basically with the help of infrared. The Space Telescope will study these exoplanets using the transit method, which involves watching out for the dimming of the light from a star as a planet passes between us and the star. With the help of ground-based telescopes, researchers can then measure the mass of the planets via the radial velocity technique. This technique measures the stellar wobble produced by the gravitational tug of a planet. The JWST itself will then do spectroscopy of the planet's atmosphere. And the JWST is equipped with coronagraphs that can do direct imaging of exoplanets near bright stars. The image of an exoplanet would just be a spot, not a grand panorama, but by studying that spot, we can learn a great deal about it. That includes its color, difference between winter and summer, vegetation, and rotation. However, the JWST will also focus on planets and other celestial bodies closer to us. NASA plans to use it to study objects in the solar system, including Mars, asteroids, comets, Kuiper Belt objects, and more. But one object that scientists can't wait to study with a new powerful telescope is Pluto. Pluto remains fascinating for many reasons. Despite losing its planet status, scientific interest in the planetoid remains at an all-time high. But one question that many observers ask is that since the JWST is designed to capture faraway objects, can it be used to study Pluto? Well, one of the latest images taken by the JWST answers the question. The powerful telescope has captured a stunning image of the last planet in the solar system, Neptune. The image caused a lot of excitement because it is the clearest view of Neptune that we've had in decades. It was captured with the near-infrared camera, or NIRCam, which also captured the planet's bright rings and fainter dust bands. The dust bands appear as fuzzy particles in between the brighter, ice-dominated rings. One scientist exclaimed it had been 3 decades since we last saw these faint dusty rings. This is also the first time the rings are seen in the infrared. To understand the picture well, you must be aware that because of the wavelength that the JWST captures, Neptune appears dark except where high-altitude clouds are present. These methane ice clouds appear as bright streaks and spots in the image. The clouds reflect sunlight before it's absorbed by methane gas. In addition, the infrared view shows a thin glowing band encircling the equator. The image also contains 7 out of Neptune's 14 known moons. The most prominent moon is Triton, which is the largest and also very bright. It reflects lots of light from the sun, making it easier to capture. So there is no doubt that the JWST can fetch us stunning images of Pluto that will expand our knowledge of the planetoid. One of the immediate tasks on Pluto for the JWST is to track something strange that is happening there. The dwarf planet's atmosphere is disappearing. As scientists report, Pluto is going through a very strange transformation which is affecting its atmosphere. They use telescopes located in the US and Mexico to study the dwarf planet in its thin atmosphere, which, made primarily of nitrogen, is like that of Earth. Pluto's atmosphere is supported by the vapor pressure of ice on its surface. For this reason, if the ice on Pluto warms up, it can drastically change the density of its atmosphere. But the thing is that scientists have been observing Pluto as it has been moving further and further away from the sun for about 25 years. During this time, the surface temperature has been dropping, and this is making Pluto's atmosphere refreeze back onto its surface as the dwarf planet gets colder and colder. And this temperature drop is not reversing soon, as Pluto is so far from the sun that as time goes on it will still get further away and colder, of course before starting to get closer to the sun in other regions of its immense orbit. Thanks to a process known as thermal inertia, Pluto's surface pressure and atmospheric density continued to rise until 2018 as Pluto accumulated residual heat from when it was closer to the Sun. However, with the inertia beginning to wear off and Pluto getting colder, more and more of its atmosphere will freeze back onto its surface and simply disappear. You can picture it as the way the Sun heats up sand on a beach. At high noon, sunlight is at its most intense, and as the sand continues soaking up the heat over the course of the afternoon, it is hottest in the late afternoon. The continued persistence of Pluto's atmosphere suggests that nitrogen ice reservoirs on Pluto's surface were kept warm by stored heat under the surface. The new data suggests they're starting to cool. But how did the scientists figure all these out from simply observing Pluto as it crossed a star? What they did was take note of the rate at which the star came in and out of view, which lasted about 2 minutes. With this info, they were able to calculate the density of Pluto's atmosphere. The method here is known as occultation. This has nothing to do with the occult, but is just what happens when one cosmic object is hidden behind another one passing in front of it. Scientists have been using this method to study Pluto since the late 80s. Pluto has its own series of amazing features that remain yet unexplored. A prime example is the Tombau Regio, the unofficial name given to the heart-shaped region observed on the surface of Pluto. A part of its landform is likened to an ice cream cone shape but is strictly covered by carbon monoxide ice. It's now iconically identified as the heart of Pluto. Right in the middle of the heart-shaped crater is another smooth region named Sputnik Planum by the probe's team, a name it now shares with Earth's first artificial satellite. Meteorite impacts are known causes of craters in most planetary bodies, but the Sputnik Planum doesn't have such a deformation. According to the geological timescale, scientists deduced that it is a relatively young region and could be about 100 million years old. There are suggestions that it might be yet to attain its permanent shape, as geological processes can continually change it. Much like the kind of streaks you can often see in Earth's arid region, the scientists observed a series of dark streaks that appear to be a few miles long and going in the same direction on the surface of Pluto's icy plains. What could have caused this? Could it be the not-so-friendly winds that frequently blow across the planet's surface? Have you ever accused somebody of having a cold heart? Perhaps the person acted with no emotion at all. Well, here's the thing. Pluto has got a heart despite how cold the planetoid is, and the heart literally dictates what Pluto does. So here is Pluto following its heart. Pluto's heart was revealed by the New Horizons spacecraft, which conducted a flyby of the planetoid. Compared to a human's heart, Pluto's heart is vast, covering up to 1 million square miles made up of nitrogen glaciers. Pluto was forced to reorient itself to face its moon Charon on the opposite side thanks to the influence of the left ventricle of its heart. The ventricle is known as Sputnik Planitia. This process is called true polar wander, when a planetary body changes its spin axis, usually in response to large geologic processes. Sputnik Planitia's current position is a cold trap where nitrogen ice has accumulated to make an ice sheet that's at least 2.5 miles or 4 kilometers thick. Thanks to the constant imbalance of that hefty mass and the effect of Charon pulling and yanking as it orbited Pluto, the dwarf planet literally tipped so the basin aligned more closely with the tidal axis between Pluto and Charon. But the event did more than just repositioning Pluto. Scientists say it was also likely responsible for cracking Pluto's surface and creating the many gigantic faults in its crust that zigzag over large portions of Pluto. The basin is thought to have formed to the northwest of its present location and closer to Pluto's north pole. And guess what? Pluto is not free yet, because should ice continue accumulating on the basin, it will continue to reorient itself. Also, the dunes on Pluto are only one of the planet's many surprises. On Pluto, the dunes are not composed of sand like that of Earth, but of solid methane ice grains that are molded by the wind. Dunes are more common than you might expect in our solar system. They exist solely on Earth, Mars, Venus, Saturn's moon, Titan, and Comet 67P. Due to the fact that these dunes are mostly undisturbed on Pluto's frozen crust, it's likely that they were produced within the last 500,000 years, or perhaps less recently. Pluto creates an age-old dilemma in this way. Polygonal shapes and features on the dwarf planet's surface indicate that it's a young and active geological system. The surface is only a few thousand years old despite the dwarf planet's 4.5 billion-year-old age overall. A thermal convective overturning of the ice is most likely the cause of this action. While scientists were baffled to realize there might be a vast liquid ocean on Pluto, the implication of the presence of the ocean is something else that is confounding them. Pluto might have volcanoes that are still active. Pluto is covered in enormous faults stretching for hundreds of miles and cutting roughly 2.5 miles into its icy, crusty surface. How did these fissures come about? Scientists say it was through the gradual freezing of an ocean beneath its surface. It is common knowledge that water expands as it freezes. When this freezing takes place under an icy crust, the expansion will push and crack the surface, just like an ice cube in your freezer. But if the temperature is low enough and the pressure high enough, water crystals may form a more compact crystal configuration, and the ice will once again contract. Models drawn up using data gathered by New Horizons confirm that Pluto has the conditions for that type of contraction, but it doesn't have any known geologic features that indicate that that contraction has occurred. This made the scientists conclude that the subsurface ocean is still in the process of freezing and potentially creating new faults on the surface today. If Pluto is an active ocean world, what that suggests is that the Kuiper Belt may be filled with other ocean worlds among its dwarf planets, dramatically expanding the number of potentially habitable places in our solar system. But while Pluto's liquid ocean likely still exists today, scientists suspect it's isolated in most places by almost 200 miles or 320 kilometers of ice. That means it probably doesn't contact the surface today, but in the past, it may have oozed through a volcanic activity called cryovolcanism. However, volcanoes on Pluto are not technically the same as those on Earth. On planet Earth, you have molten lava spitting, drooling, bubbling, and erupting from underwater fissures through volcanoes that sit miles high in and protrude from the oceans like in Hawaii. But when it comes to Pluto, evidence points to a kind of cold, slushy cryolava that has poured over the surface at various points. Remember cryovolcanism. Wright Mons and Picard Mons, two large mountains located to the south of Sputnik Planitia, have deep central pits that scientists discovered are likely to be the mouths of cryovolcanoes. These structures are unique in the solar system. To the west of Sputnik is Viking Terra, covered in long fractures and grabens that show evidence of cryolavas once flowing all over the surface there too. And when you go further west of Sputnik Planitia, there is the Virgil Fosse region. Here, ammonia-rich cryolavas may have burst to the surface and covered an area of several thousand square kilometers in red-colored organic molecules no more than 1 billion years ago, if not even more recently. And still on volcanoes, Pluto's moon Charon has a volcanic history too, and its past may help us understand other icy planets. Thanks to New Horizons, which also captured captivating photos of Charon, scientists have been able to study the moon's geology too. But of course, the JWST will enable scientists to study this moon on a long-term basis. On the side of Charon that New Horizons imaged in high resolution, there are two distinct terrain types. One is an immense southward stretching plain officially known as Vulcan Planitia, which is at least the size of California, and there is a rugged terrain called Oz Terra that stretches northward to Charon's North Pole. Both seem to have formed from the freezing and expansion of an ancient ocean beneath Charon's crust. The mountain terrain of Oz Terra was the result of moderate expansion in the north, while the expansion in the south forced its way through vents, cracks, and other openings as cryolava spilling across the surface. Astronomers have found similar features on some icy moons all over the solar system. The formation also took place on Neptune's giant moon Triton, Saturn's moon Tethys, Dione, and Enceladus, and Uranus's moons Miranda and Ariel. With the detailed images of Charon obtained from New Horizons, the models of Charon's past is an invaluable tool in understanding the volcanic and geologic activity of those other icy worlds. This is one of the reasons scientists are drawn to Pluto. Many findings on the planetoid shed light on erstwhile puzzling discoveries in other parts of the solar system and beyond. How did Pluto form? Even though Pluto today is one of the coldest places in the universe, it might have had a violently hot start according to new discoveries by scientists. Before, astronomers thought Pluto's ancient subsurface sea slowly formed over millions of years as radioactive decay melted ice on the dwarf planet. However, new findings of scientists questioning that theory. A team of scientists combed through vast amounts of images of Pluto taken by the New Horizons spacecraft for clues as to the origin of the dwarf planet. This is possible thanks to the sculpted valleys and mountains on Pluto, which can reveal details about how the dwarf planet was formed. The same thing is obtainable on the Earth with its own mountains and valleys. After the analysis of the dwarf planet's bizarre surface features, the team created a series of computer models that investigated the different methods through which the planet could have formed. The scientists said if Pluto started cold and the ice melted internally, then Pluto would have contracted. There would be telltale signs such as compression fractures on its surface. However, if Pluto started hot, it should have expanded as the ocean froze, and there would be telltale signs of extension features on the surface. But the team only found evidence of extensional features, pointing to the fact that a short violent start could have given way to an early ocean. With this realization, the team then calculated what it would take for the dwarf planet to start off as a heated body. There are two ways Pluto could have generated the heat at the early stage. Energy from radioactive decay warmed the proto-dwarf planet, or it was bombarded by nearby material, and the energy from these impacts would have spurred melting. They concluded the second scenario was more likely. If Pluto's formation took too long, the heat created by the gravitational energy of these impacts would have escaped into space. This shows that the formation of Pluto must have been a brisk affair. But of course, in the timeline of the universe, that brisk time could have been about 30,000 years. One other thing scientists have discovered about Pluto is something it has in common with the Earth and Mars. It has actively flowing glaciers. Researchers discovered dozens of nitrogen ice glaciers that course down from pitted highlands into the basin and create valleys as they go into the east of Sputnik Planitia. Scientists postulate this glacier ice is a result of seasonal and mega-seasonal cycles of nitrogen ices that sublimate from ice to vapor, move around Pluto, and then freeze back on the surface. Again, these glaciers are not like the water ice glaciers found on Earth. For instance, any melt within them won't fall toward the bottom of the glacier, it will actually go to the top, and this is because liquid nitrogen is less dense than solid nitrogen. When the liquid nitrogen makes it to the top of the glacier, it may erupt as jets or geysers. Apart from this, some of Pluto's surface is made of water ice, which is slightly less dense than nitrogen ice. So when Pluto's glaciers course through the surface, some of those water ice rocks will rise up through the glacier where they float like icebergs. You can see some of these icebergs in some of the photos of Sputnik Planitia that New Horizons sent back to Earth. Sputnik Planitia is Pluto's largest known glacier. It stretches at more than 620,000 miles or 1 million kilometers, which is about the combined sizes of Oklahoma and Texas in the US. When you examine photos of Pluto, you will likely spot something found nowhere else in the solar system. It is a network of strange-looking polygonal shapes in the ice. Each of these cells is not less than 6 miles across. While they may appear like cells viewed under a microscope, in reality, they are far from these. They are actually evidence of Pluto's internal heat attempting to escape from underneath the glacier. These cause them to form bubbles of upwelling and downwelling nitrogen ice, something like a hot lava lamp. Warm ice rises up into the center of the cells, while cold ice sinks along their margins. There's nothing like it in any of Earth's glaciers or anywhere else in the solar system that scientists are exploring. How did Pluto lose its standing as a planet? Pluto enjoyed this status for decades until the International Astronomical Union changed the definition of a planet by setting forth some basic descriptions that a planet must meet. Unfortunately, Pluto did not meet all of these new requirements, forcing geography textbooks to be rewritten all over the world. So what makes a planet a planet? According to the IAU, a planet must orbit around the Sun, must have sufficient mass to assume hydrostatic equilibrium or a nearly round shape, and must have cleared the neighborhood around its orbit. The problem was the last one. Pluto has not managed to clear its neighborhood of other objects or become gravitationally dominant. It has not been able to expel other bodies of a similar size to it. As a consolation, Pluto was given the title of a dwarf planet, and the number of planets dropped from 9 to 8. A recent photo analysis revealed a rough patch on Pluto that is unlike anything else on the small world or in our cosmic vicinity. This lumpy region is home to a smattering of unusually enormous ice volcanoes unlike anything else we've ever seen in the solar system. The location is southwest of the Sputnik-Planitia ice sheet, covering 621 miles 1,000 kilometers of the ancient impact basin. It mostly consists of lumpy water ice and is covered in volcanic domes. Wright Mons and Pickard Mons are two of the largest. Pickard Mons is around 22,965 feet 7 kilometers high and 139 miles 225 kilometers wide, whereas Wright Mons is roughly 13,123 to 16,404 feet 4 to 5 kilometers tall and spans 93 miles 150 kilometers. The Mauna Loa volcano in Hawaii is one of the largest volcanoes on Earth, and Wright Mons is thought to be comparable in size. Some of the domes seen in the photos combine to form even larger mountains, but what may have caused them to exist? It all boils down to ice volcanoes. Ice volcanoes have been discovered in other parts of the solar system. They produce a new landscape by moving material from the subsurface to the surface. When the water reached the freezing temperatures of Pluto's surface, it swiftly turned to ice. Pluto's snow-covered mountains look like they belong on Earth, but they are in fact completely different from our own planet. It's hard to compare the appearance of these features to any other volcanoes in the solar system, be it icy or rocky. They started out as mountains, but there is no caldera at the top, and they are covered in big bumps. Concerning these glaciers on Pluto, scientists have discovered something else that is quite fascinating about them. They grow with the seasons. How does this growth take place? First of all, while it was always cold on Pluto, the temperature does not remain the same. It can vary from minus 418 to minus 364 degrees Fahrenheit, meaning there are warmer seasons on the dwarf planet. When it's warmer, the methane and nitrogen molecules freely rotate in the solids, as the molecules are not bound together very well. When they performed a thermal expansion study of Pluto's methane and nitrogen, a team of researchers found that these molecules change orientation as the temperature warms. The researchers also learned more about how the dwarf planet's methane and nitrogen behave in general. Methane and nitrogen molecules can flow at extremely low temperatures because of the arrangement of their molecules in their crystal structures. The team recreated conditions on Pluto using Wombat, a high-intensity neutron diffractometer located in the Opal Neutron Guide Hall at the Australian Centre for Neutron Scattering. The researchers observed changing densities in the molecules in response to temperature. But while they expected a straightforward study, they came away with some surprising outcomes. Nitrogen has two crystal structures when subjected to the range of temperatures seen on Pluto. The molecules can cool into an ordered structure, which is the alpha nitrogen phase, and at this point there is a big volume drop, whereas at a slightly higher temperature, around minus 380.47 degrees Fahrenheit, the nitrogen molecules are freely rotating in a plastic state. Can life in any form survive on Pluto? Due to the extreme conditions on Pluto, there is no chance of life on the surface. The temperature is simply too cold. Not only does water freeze solid at these temperatures, but other liquids and gases that are present on Pluto's surface, such as methane, nitrogen gas, and carbon monoxide, also freeze solid. These compounds have much lower freezing points than water, and so the chance of life surviving under these conditions is slim to nil. The pressure on Pluto is also between 1 million and 100,000 times less than Earth's atmospheric pressure. However, that life cannot exist on the surface of Pluto does not rule out the possibility of life being found inside the planet. What does the interior of Pluto look like? Scientists say that Pluto has a differentiated internal structure, with rocky material that has settled into a dense core surrounded by a mantle of ice. The diameter of the core is about 1,700 kilometers, whereas the ice layer is estimated to be 100 to 180 kilometers thick at the core mantle boundary. Even though Pluto is freezing on the surface, scientists say there might be a liquid ocean of water within Pluto. How? Well, the decay of radioactive elements would eventually heat the ices enough for the rock to separate from them. However, scientists predict the conditions on Pluto may change in the future, which will allow life to exist on the dwarf planet. But that will actually spell disaster for the Earth. It is true that Pluto for now is outside the habitable zone surrounding the Sun, but the Sun will eventually expand into a red giant, increasing the amount of energy it gives off for a period of several millions of years. Once the core hydrogen is exhausted, the Sun will expand into a subgiant phase and slowly double in size over maybe 500 million years. As it grows in size, the Sun will consume the inner planets, including our very own Earth. But the habitable zone will spread to the outer solar system. By that time, the Sun would have become so hot that the Earth will be hotter than Venus is today. The Sun will then expand more rapidly over another 500 million years until it is over 200 times larger than it is today and a couple of thousand times brighter. This then starts the red giant branch or RGB phase, which will last around 1 billion years. Within this period, the Sun will lose around a third of its mass. Many objects in the Kuiper belt will warm up significantly, and that will include Pluto. However, given the composition of these bodies and the relatively short window in which they will be warmer and wetter, it's not likely that life will evolve from scratch on Pluto. Most likely, we would have to transport it there from Earth, assuming humanity is still living, and seed Pluto and other surviving bodies with vegetation and terrestrial organisms. Meanwhile, you don't have to worry, these cataclysmic cosmic events are not scheduled to start until about 5.4 billion years from now. Remember Pluto's heart that we mentioned earlier? The feature has other effects on the dwarf planet. It controls the atmosphere and climate. You can say that the heart beats daily and the rhythmic beat influences Pluto's atmosphere and climate, which is basically similar to how Greenland and Antarctica control the climate on Earth. So how does this happen? Nitrogen ices in Pluto's heart-shaped Tombaugh Regio go through a cycle every day. They sublime from ice to vapor under the sunlight and condense back on the surface during the frigid night. Each time this happens, it's like a heartbeat. It drives nitrogen winds that circulate around the planet at up to 20 miles per hour. And scientists have been able to create sophisticated weather forecast models using New Horizons data. These show that as these ices sublime in the most northern parts of Pluto's icy heart and freeze out in the southern part, they force brisk winds in a westward direction. This is strangely in the opposite direction of how Pluto spins eastward. Those westward winds crashing into the rugged topography at the fringes of Pluto's heart are the reason that there are wind streaks on the western edge of Sputnik Planitia. They're also responsible for the dunes on Pluto. Pluto is known for its ice, but what happens to Pluto if it gets close enough to the Sun? If it did ever get close enough to the Sun, much of the surface ice would eventually thaw, and its atmospheric layers would be at their thinnest, lacking much of its carbon monoxide ice, but mostly retaining its nitrogen and a little bit of methane. At that point, scientists might consider Pluto to be in its most habitable form. Although we have no idea what to do about its low gravity, which is about 1/20th of the Earth's. Hence, its atmosphere appears much denser and higher than Earth's, and the further it strays away from the Sun, the denser it becomes as the atmosphere freezes until it phases out of view. When considered at its thinnest, scientists have surmised that it restricts the flow of fluids. One proof of this is provided by the New Horizons in an image of a frozen lake in the Tombaugh Regio. They also saw what looked like water channels. We join them in thinking about the possibility of the planet having an atmosphere 40 times denser than the red planet, talking about Mars, of course. There were also observations of certain cloud forms in the atmosphere. The clouds were formed at low altitudes with technically the same sizes, but the major components of these clouds are thought to include acetylene, ethane, and hydrogen cyanide. Did you also know that the dwarf planet spins back from east to west, which opposes everything that makes up the characteristics of the major planets in our solar system? There's a lot of information waiting to be discovered about the planet. NASA's New Horizons mission is the only mission dedicated to observing Pluto, its moons, and every other world that may exist beyond it in the Kuiper belt. Not knowing much about the planet means we don't know if the probe will survive the harsh environment that awaits it beyond Pluto's orbit. The fact it already has 5 moons as satellites has not done much justice to easing fears that the spacecraft could collide with debris or undiscovered moons and eventually be crushed under their weight. For now, we expect it to show us more up-close images of Pluto as we anticipate a better understanding of what thrives on Pluto. One other amazing thing about Pluto is that it has almost no little crater, and this is something it has in common with its moon Charon. While this may look like yet another quirk of a quirky celestial body, the near absence of little craters has big implications. Craters are among the most common things on the surface of planets anywhere in space, but if there's one abnormal thing about the Pluto system, it is the fact that Pluto nor Charon have any small craters. It is a matter of go big or go home on this dwarf planet that's at the edge of the solar system. Why scientists found it surprising to find fewer small craters than they thought was that it means there are also fewer small Kuiper Belt objects than they expected. Pouring through the crater images from New Horizons, they got to see that few objects less than about a mile in diameter bombarded either world. They reached this conclusion because there is no reason to believe tectonic activity would have preferentially wiped the surface clean of these small craters. The only logical reason is that the Kuiper Belt is mostly devoid of very small objects. This result tells us about more than just Pluto. It tells astronomers, or at least give them clues about how the solar system formed, because they reveal the population of building blocks of larger objects, like even perhaps Earth. For decades, scientists believed that Pluto's stony core lacked the internal energy necessary to stoke volcanoes. They believed that several eruptions would have been required to form the area. Additionally, the lack of impact craters in the area, which can be observed across Pluto's surface, shows that the ice volcanoes were active very recently and that Pluto's interior has more residual heat than expected, implying that our understanding of planetary systems is incomplete. As far as geological timescales go, the ice volcanoes may have been active as recently as 100 million or 200 million years ago. Observing Pluto's ice volcano would be an experience unlike anything you've ever seen before. On this dwarf planet, instead of erupting gases and molten rock, the cryovolcanoes on this dwarf planet expel massive amounts of ice, most likely frozen water. While flowing out of its volcanic vent onto Pluto's surface, the frozen material would most likely be a slushy mix of ice and water, or more like toothpaste. The explanation for this is that liquid water cannot last long on Pluto's surface due to its extreme temperature. In any event, the flow of material created the gigantic domes that we see today and the bumpy topography that can be observed across this region. The team working on New Horizons was only able to observe the region for about a day as it flew over this region. Therefore, they were unable to observe any present ice volcano activity. In theory, the ice volcanoes could still be active at this time. They could be like Earth's dormant volcanoes, which become active again after a period of inactivity. As mentioned earlier, even though Earth and Pluto are separated by more than 5 billion kilometers, the two have lots of things in common. One of them is the color of the sky. When you look up from the surface of the Earth on a bright day, what you see is a blue expanse. It is the same on Pluto, as its sky is also blue in color. While photos of Pluto released by NASA show a reddish-brown surface, Pluto's atmosphere actually has a blue haze. The discovery was made from data collected by the New Horizons spacecraft during its flyby. The question is, how does a dwarf planet known to be reddish going on pink even have a blue sky? The answer is tholins. That may sound like something you've never heard before, but tholins are particles formed after sunlight triggers chemical reactions between nitrogen and methane in the atmosphere. The process was first observed on Titan, Saturn's moon, and in the case of Pluto, the particles are likely gray or red. However, they scatter blue light, making it the most visible to our eye. A blue sky is usually the result of very small particles scattering sunlight. On Earth, those particles are very tiny nitrogen molecules. But out there on Pluto, where they appear to be larger but are still relatively small, these soot-like particles are called tholins. However, these tholins don't stay up forever. They fall to the surface of Pluto and form reddish gunk. And there is another magical coloration phenomenon on Pluto. While scientists have detected exposed regions of water ice on Pluto, the sections where the ice is found are bright red when NASA scientists false color the photos of the planet. Why do the regions containing ice appear reddish? The scientists admit they don't know yet, and they are trying to understand the relationship between water ice and the reddish tholin colorants on the planetoid's surface. We are expecting new information in this area once the scientists get to use the JWST to study Pluto in great detail. However, when it comes to snow-capped mountains, which the Earth and Pluto also have in common, there are some fascinating differences. For example, while snowcaps form from the bottom to the top here on the Earth, the reverse is the case on Pluto. That is, the snowcap is formed from the top to the bottom. When NASA's New Horizons spacecraft flew by Pluto in 2015, it showed a complex and diverse landscape on the planetoid. Pluto's frozen surface varies greatly. It features regions dominated by ice, and we are talking about different types of ice here, including frozen methane, frozen nitrogen, and even water ice. The water ice is so cold that it's harder than a rock, and that is the material the mountains on Pluto are made of. these mountains of ice were discovered to be covered with frost, which appears very similar to snow-capped mountains on Earth. The regions known as Pigafetta Montes and Elcano Montes on the dark equatorial Cthulhu region of Pluto are full of this type of mountain. In the former region, summits can reach 2.2 miles above the base, and they have shining caps from the 1-mile mark upwards. The same frost was found on the crater rims and walls in the Cthulhu region, with the same characteristics of appearing as you approach the tallest points. On the Earth, mountain snowcaps form when moist winds rise upslope and cool as temperatures drop with increasing altitude. The rising moisture condenses as it gets colder and forms snow on the tops of mountains. But what is the snow-like frost on Pluto made of? Some scientists suggested methane, but they were not sure whether it was pure methane or methane diluted with some nitrogen. Scientists needed to identify the composition of the frost because without knowing the composition, it is impossible to trace its origin. So they studied high-resolution data from New Horizon, and it revealed that the snow-capped frost contained almost pure methane ice. Since methane is present in limited quantity on Pluto, just as water vapor on Earth, the researchers felt the high-altitude frost on Pluto should form like on the Earth, but of course, the reverse was the case, and that was due to a unique atmospheric process on the dwarf planet. In fact, it shocked the researchers that two very similar landscapes on Earth and Pluto could be formed by two dissimilar processes. With the help of computer simulations, the researchers discovered that atmospheric circulation on Pluto might concentrate methane gas a few miles above the plains of the dwarf planet. This in turn can result in methane condensing as frost on mountaintops. Pluto has a thin atmosphere that gets heated by the sun. This atmosphere gets warmer as altitude increases, whereas Pluto's surface temperature remains uniformly cold. The atmosphere has more gaseous methane at its warmer, higher altitudes, allowing for that gas to saturate and freeze directly on the mountain peaks tall enough to reach the enriched zone. But at lower altitudes, the concentration of gaseous methane is lower and it cannot condense. Pluto may no longer qualify as a planet, but researchers claim it may have something in common with the planets closest to it. Many people are fascinated by the ring system surrounding some of the gas planets like Jupiter, Saturn, Uranus, and Neptune. However, it is possible that Pluto has rings too. Being so close, it would be rather odd for Pluto not to have rings of its own. Some astronomers now contend that Pluto has rings, but we have not noticed them yet. According to one of them, Henry Throop, who's actively searching for evidence of these rings, Pluto's rings would be too faint and too small to see directly. However, there is some hope that this particular detail could be studied more, because occasionally Pluto passes in front of a distant star. When this happens, the star's light blinks out like a moth blocking out the beam from a flashlight. What scientists will do is search through the observations to try to find any hint that the starlight was being blocked by the rings of Pluto. And if there is any doubt that Pluto could have rings, scientists have found rings on another world that is 2 billion kilometers further out than Pluto. When scientists made this discovery, it was the most distant point in the solar system where rings had been detected. The ring was found around Haumea, a dwarf planet like Pluto. Before this, scientists found 2 rings around Chariklo, which is a rock that is only about 250 kilometers across. It was located between the orbits of Saturn and Uranus. However, similar to the same method scientists planned to find the rings on Pluto, astronomers spotted the rings on Haumea when it passed in front of a dim red star in the constellation of Boötes. This finding was confirmed by a dozen telescopes in 6 European countries. The ring is 70 kilometers wide and about 29,290 kilometers in the center of Haumea. Scientists hope to use Haumea's many odd properties to get clues on how it came to have a ring. The dwarf planet is shaped like an egg, which may be a result of its whirlwind rotation. Haumea completes a full spin every 3 hours and 55 minutes, compared to Pluto, an almost perfectly round body that rotates every 6.4 Earth days. So in just a day, a resident on Haumea's equator would see 6 sunrises and 6 sunsets. Just like Pluto, Haumea has 2 small moons. In fact, the similarities between these 2 planetoids are so much that astronomers suspect that all these traits are linked. Possibly a large object may have hit Haumea, causing it to spin and eject debris that formed both the ring and the moons. This impact would also explain another phenomenon. Several other bodies travel on almost the same path around the Sun as Haumea and share its composition, having water ice on their surfaces. They could all have been born during the same initial smash-up. so Haimea's rings could lead us to Pluto's rings. Now, you have heard us call Charon Pluto's moon. However, the truth is that Charon and Pluto could pass as a dual dwarf planet system. Charon is the largest of Pluto's known 5 moons and was discovered in 1978 by 2 scientists named James Christie and Robert Harrington. The duo discovered that some images of Pluto were strangely elongated and a blob appeared to move around Pluto. Another thing that jumped at them was that the direction of the strange elongation cycled back and forth over 6.39 days, which corresponded to Pluto's period of rotation. This prompted them to search through previous images of Pluto, and they established it was a pattern, and this led to the discovery of the largest moon. Pluto and Charon have a unique relationship. The moon is half the size of Pluto, making it the largest known satellite relative to its parent body. Pluto and Charon always turn the same side to each other, a phenomenon known as tidal locking. The Earth and its moon are also tidally locked. Pluto and Charon are separated by 12,200 miles and the only known double dwarf planet system in the solar system. A high-contrast array of bright and dark features covers Pluto's surface, while on Charon you will only find a dark polar region interrupting a generally more uniform light grey terrain. Meanwhile, the reddish materials that appear on Pluto are not present on Charon. Also, Pluto has a significant atmosphere, something that is missing on its moon. And Pluto has exotic ices. Frozen nitrogen, methane, and carbon monoxide have been found, but Charon's surface is made of frozen water and ammonia compounds. The interior of Pluto is mostly rock, while Charon is equal parts rock and water ice. Fun fact about Charon, Christie chose the name because the first 4 letters match his wife's name, Charlene. Charon, however, is the name of the mythological ferryman that carried souls across the river Acheron, one of the 5 mythical rivers that surrounded the mythic Pluto underworld.